Right, so what we got over here is a solid state switch. What I need to do is design a little enclosure to hold this resistor and diode, which is used for triggering this SCR. So let's get rid of that. So what we want to do is we want to have this located somewhere over here. So it's just going to be a little plastic enclosure in PLA. It might even become EPLA because this gets hot. Engineering PLA can handle higher temperatures, but I'll do the prototype in ordinary PLA. So we need something that is going to sit over here, held down by some nuts that go into these T-slots over here. So let us check that dimension. That's 8. And this dimension over here, the slot, is 5. So what I could also do is just whip out that Allen cap screw and check its dimension. That then we'll know for sure what's going to fit. Because what we don't want to do is make a hole for this fastener over here that's going to be too small. So let's see, that's 4. I think that's a 5mm screw, but we can check. So we're going to be looking at a bit of CAD work today. I've already got it flashed up there on the screen. Let's have a look at that. 5mm. So we'll go with 5. So let's put that back. Like so. And let's measure up the dimension over here. What we need to do in our CAD is store new project by hitting Control N, click in there, Control Save, Documents, Mechanical Sundry. We'll call that solid state switch switch shear enclosure. So let's start off with how wide it needs to be. Let's go with 100. So that's from there to there. Then we need to worry about depth. It doesn't need to be terribly wide, so I'm going to go with 30. So now CAD, I am going to hit L for line, make that 100, draw on the y-axis, hit 30, draw X, hit 100, draw Y downwards again, hit 30, and there's our rectangle. Now I need to center that on the origin, so I'm going to move that down 5 millimeter. And I'm going to move it down like that, 15 millimeters. Now it's centered on the origin. So now we need to bring it up. So I know hit H, which is a home view. Hit P for pull. I'm going to make that base the default 2 millimeters that I like so. Okay, now I'm going to go back to the vertical view again, select that plane. Now we need the mounting holes. So that is going to be 80 millimeters. Very good. C for circle. And because we know it's 100, we can go 10 in from each side. And what I'm going to do is make that 5.5 millimeters to allow for the 5 millimeters of shrinkage that we get on inner dimensions. Now we need to make those holes through to the bottom. So I need H, P, hold down Control, select them both, pull them through. Very good. Select that plane again. Now we need a couple of things here. This is going to be the base. So let's start off by drawing the outer edge. Like so. So that'll be 96. And that'll be 26. And that'll be 96. So that's our outer edge designed. Now I'm going to pull it up a little bit again by hitting H, P, selecting that surface and pulling it up by 2 millimeters. Now what I am going to do is design the top cover so that it fits with the inner lip, which engages on the inner surface, like so. Going to get rid of those surfaces over there. Now we need some openings for the wires, and we need to hold this resistor. So we need a little slot for that to go into to make that captive. So let's measure that diameter. Let's do that first. What do we need here? 7 millimeters and 35. Okay, let's see what we can do. So let's start off with a rectangle. 735. Well, let's just start drawing it. It's going to be a half a millimeter left over by the time we've got it centered onto the origin. M for move, and yes, there's a half a millimeter. 0.5, 0.5, -1. What are we doing? Let's just fix that. 0.5. Now you want to bring it across 1.5. Okay, now it's centered on the origin. You can see the half millimeter difference there. So now we need an outer edge to hold it. So let's go back to D for design mode. We want a line. Now I'm going to go for that, like so. I'm just doing this by eye instead of doing the maths, but that's also okay. Escape. Pull. Select that surface. And we said that that is 7 millimeters tall. Now we need some slots for the wire leads to poke through. Let's make that 2 millimeters. And another one on this side. Add to home. Pull. Select them both. And I'm going to go down 4 millimeters like so. So that should give us plenty of distance from the bottom to the top so the lead can stick out. That should be just fine. Alright, now we need a place for the wires to come out. I think I'm going to do it on this side. Like so. Go over here and I'll make a 3 millimeter slot. Pull, select those two, and we said that that was 2. So what we need to do is raise this up a little bit. So I think I'm going to bring that up by a millimeter, so that basically becomes a 3 millimeter opening then. So that's the base designed. Now we just need a lid. So I'm going to select that plane. Let's do it. Let's hit S for select. Control C. Back here. Control V. Control M for move. M for move, sorry. And slide that copy over like so. Now what we want to do is we want to copy that surface, Control C, Control V, M, and 32 millimeters. Now we're left with a copy of it. Now we need to bring it up, so I'm going to bring that up by 2. Take that surface and take it down 3 millimeters, and that leaves us with a copy of the lid. And we want this to be contiguous, so I'm going to join those two together like that. Now we need an inner surface, so what I'm going to do is bring this in by 1.75, because that's going to give us a 0.5 millimeter that we need to allow for actually. Now let's change that. Let's make that 2. I need to fix it on the outer dimension, not the inner. Bring that in by 2. Rotate. Bring it in by 2. And bring that in by 2. Right. Okay, now I'm going to select that surface, and I'm going to make that the same size, then I'll shrink it. Escape. I'm going to bring that up by 2 millimeters. Then we want to shrink it 0.25 so that it'll slide in there afterwards. So 0.25 is giving us a total of 0.5 millimeter that we're shrinking it on the outer dimension. 0.25. And so then the same here. 0.25. Right. Z. Now we need to check our dimensions. So I'm going to hit E for caliper. Select that edge. Select that edge. There we have it. 95.5. Now if you check that dimension, we have 96. Let's check our vertical dimensions. That's 926. That one and that one. Hang on. That one and that one. 25.5. Let's get rid of that surface. So what I need to do is reinforce a little bit the lid a little bit at this point. So what I'm going to do is hit C for circle and add about 1 millimeter to there. Go hit D for design. E. Let's see how tall it needs to be. So we know we got if I click on that, it gives us 3. Click on that 5. If I select them both, we get overall length of 8 millimeters. So now we know getting rid of those, that we need to pull them up by 8 millimeters. So I'm going to select them both and pull them up by 8 millimeters. Let's just undo that. I selected a pull and not select the edge, and bring it back up to 8. And then what I'm going to do is give that a nice fillet, make it pretty, like so. So now we basically have our box, places for the wires. What I'm going to do as well, select that, Control C, move 32. So that is now not copied it. What I'm going to do, I want to that one and that one, Control C, M for move, select horizontal. Let's try that again. Control C, Control V, then move. Alright, 32 millimeters. Now I need to move that down a little bit. Let's see how far we need to go. We hit E for edge. Select that plane. And that one, that's 2 millimeters. So if I hit M, Control M, Control, select the blue arrow, move it down 2, we end up there. Now hit P, and I move it down 5 millimeters. 4, 3. Now what are we doing here? Let's measure that one. That's 5, so P 5. Okay. So now that is proud, so I need to pull it down about 2 millimeters to make room for that to butt up against it. So there's 2 millimeters. So now if you take that, S for select, and we make them transparent, we should be able to flip it over. So I'm going to select that one, rotate it 180 degrees. Now when I move it across 32 degrees, we should see things like that. It looks as though that's all going to fit together very nicely. Except for that post, there's a problem there. I need to take 2 millimeters away from that. Right. Let's fix that. So I hit pull, take it down 2 millimeters, 2, -2, that should have fixed my little problem, I think. So if I hit E, and I select those surfaces, there should be 1 millimeter difference. Yeah, okay, we're good now. So I think that's pretty much our little resistor holder sorted. So now I go back to design, escape, export options, 3D print STL. It's going to become an STL. Right, let's see if it'll slice. Let's open up layer slicer, add it in there. Mechanical sundry, trigger enclosure. It did not complain. Very good. So that's what that's going to look like. Let's tell it to slice. I'm not going to use a raft. Temperatures are okay. The infill is going to be standard and all that sort of stuff. Slice it. Preview. Let's see what that looks like. It's going to take 2 hours and 5 minutes to make. So I think we are good. That's it. So that concludes this video. This video was just about doing the design and how I go from start to finish, measuring up, doing the CAD work, and how we check the thing, then go to slicing, checking it once again, and then off it goes to the printer. So that's going to wrap up this design tutorial, which was a full tutorial. We got a practical example over here, a little box that we want to mount here to contain this resistor and the diode as well over there. We'll fit that in there as well, and it's got square edges for now, but that's okay. I can fix that later. For now we're just doing a basic design. It's neat enough as it is. So, ladies and gentlemen, thank you for joining me here today. Have an awesome day further. Please check back later for more. I love having you here. And take care. Cheers.